Alright, welcome back ladies and gentlemen. In this video we're gonna go over the slider connection. It's useful, and I guess one of the applications would be, I guess, if you're trying to model, let's say, a syringe or something, or I don't know, a squirt gun or something. um, it's a slider connection that allows you to control the linear movement. It's only linear. But let's get into it. I'm gonna bring in the same link again, and I don't know where it is. Lost. Okay, so there it is. So we're gonna go over and we're gonna select a slider connection, and we're gonna go to placement, and it's again asking us for axis alignment. I'm gonna select the axes. I'm gonna say turn them on, and what essentially it's asking me is where which path am I going to use to have this slider connection made. So the axes you select is essentially the direction the thing is going to slide in. That's the main purpose of this axis, and it doesn't necessarily have to be an axis. It can just be a line. I think. Can it? No, it can't be. So I guess it can't be a line. Axes of rotation. Why can't it be a line? I'm pretty sure it can be a line. Yep, it can be a line. Yeah, I'm pretty. I don't know why I felt like it wasn't. Okay, so any linear thing, any straight line that you might have, any edge you can use as constraint for the axes of alignment. Axes. I think I'm saying that weird. Axis alignment. Yeah, and it doesn't necessarily have to be a round edge, so just keep that in mind. I'm going to use that because it makes sense for what I'm about to do, but just keep that in mind that you don't have to have round shapes to have slider connections. You can do those in squares. um, okay, so let's do it. Placement, axes of alignment. I'm going to select the axes again, but this time I'm going to select the actual axes. um, Now it's asking me for rotation. Now, since this is a slider connection, we can't have rotation. It's only allowed to slide linearly back and forth. So right now we got 2 degrees of freedom. We can't have that in a slider connection. It's allowed to rotate and it's allowed to go back and forth. We can only have it go back and forth, and that's our end goal here, which is what we'll do. So how would you go about this? Um, this is something that could be tricky sometimes, because sometimes we turn off these datum features and we forget that we can use these datum features to set our constraints. Um, but some of these constraints are very easy to make if you activate some only particular datum features like planes. So all I'm gonna say is essentially, I'm gonna say this plane right here, this horizontal plane, or the vertical plane for this part is going to be coincident, and I don't really have to say it. It's automatically selected because that's the default, and you can't really change that either, by the way. um, and that's the default right there. It's gonna say I'm gonna remain coincident with this plane right here. What that means is, I'm not allowed to rotate anymore. I'm saying that this plane almost becomes rigid relative to this plane. And you'll notice that the rotational degree of freedom went away. Before, this was a blue arrow in the rotational degree of freedom indicator right here. If you watch again right here, it's allowed to rotate. But the moment I select that plane, it's immediately going back to a static almost thing that doesn't move in any rotational. um, I have trapped myself in my words. I don't know how to English right now. Okay, so you get the point. It's only allowed to move in these 2 directions. But if we just leave it like this, it's gonna go infinity to infinity. There's nothing really. There's no physics engine running in the background here that's gonna say, oh, okay, it's gonna stay in it within reasonable limits. Um, so we have to kind of give it some intelligence, and we can do that, and we can say it's only allowed to move within a particular distance. So we go to the translation axes. And don't be fooled by these names. You don't have to select axes or edges. You can select a surface, which is what I'm gonna do. I'm gonna select the surface from the part, and then I'm gonna select the surface from the main assembly. And right there it gives me a distance figure, and I'm gonna say it's 0. The moment I say 0, the two surfaces that I selected are immediately coincident with each other. And I'm gonna keep using the term, by the way, coincident. Coincident means, you know, they're in the same plane, but you should know that by now. So this is our 0, and I'm gonna say our minimum limit is 0. So let's see what happens when we just set the minimum limit. Just the minimum. We're not gonna mess with this maximum yet. So I'm gonna hit OK, and I'm gonna click Control. I'm gonna press Control Alt, and then I'm gonna click and drag. So I'm only allowed to go in the forward direction, I guess. So when I click and drag and I try to go backwards like this, at that point where we set 0, it's not allowing me to go back from that. It's only allowing me to go forward. So we know our minimum is right here. And then I'm gonna go to the definition again, edit definition, and translation axes. Now we're gonna set a maximum limit, and again, hold on a second. So we want it to be realistic, right? So we want the minimum limit to be the distance between this surface right here and the surface in between. So I guess a better way to show that would be, let me just go to the top view or something. So this little gap right here that you see here, this tiny gap, that's gonna be my maximum distance, because I want it to be able to slide just here and then stop. Right now it's going further, but I want it to stop automatically like it does at a minimum limit. So I'm gonna go to edit definition. Actually no, I don't really know what that distance is. So let's use the measure tool. I think this is the first time I'm using the measure tool in assembly. Okay, so I'm gonna select the surface. I'm gonna select, what do I have selected? Distance? Yeah, so I'm gonna measure the distance between this surface, and then I'm gonna hold down Control. Then I'm gonna select the surface I wanna get the distance to. Let's see, right here. Okay, so it's 0.25, and it's showing me the surfaces selected with this little line right here with the black spheres or circles, whatever you want to call it. And that's the distance. And that's how the measure tool sometimes comes in handy. You know, it helps you understand the physical constraints that you need to place, and just understand how physically the part might need to be constrained. So let's go back to that edit definition, and for the maximum now we're gonna say 0.25, because that was the distance of our gap, and we're gonna say that's the maximum distance it's allowed to move, and we're gonna hit OK. So let's see what happens. Our minimum was 0. This is our 0, and maximum is 0.25. And look at that. I'm clicking and I'm dragging. Again, I'm doing this by pressing down Control Alt, and then I'm clicking and dragging, and it's not going further than that 0.25 mark, and it's only going between these two marks. And I guess this is to some degree synonymous to, you know, modeling a syringe or something, where you would have a fairly defined distance to which a certain push pin would be able to move, and it's not allowed to rotate either. If I haven't really worked with syringes as much, but I guess you get the point. It's allowed to slide back and forth. So that's a slider connection, and I'm going to quickly go over some of the other connections that I don't really need to show. Rigid connection is essentially, you know, it's a place where the part remains static essentially. So it's not going to have any degree of freedom, and you're going to have to select surfaces accordingly. So right now I already have these two surfaces selected, these axes. You constrained, let's see. Okay. So when I make a coincident, a restrained constraint, you know, it's not really allowed to move anywhere. I'm trying to move it right now. Drag component, nothing's happening. And by the way, I'm not gonna, as we get into this course, I'm not gonna explain what every single one of these means. You're gonna need to mess around with it, because I think that's the best way to learn. Kind of mess around with it yourself, because I think you're familiar with the interface by now, and I think it's not that difficult. I don't think it is, at least. But that's it. It's a very straightforward constraint that I've never really used. Unless you're making static assemblies just to show how your assembly looks like and how a part looks like, how a concept looks like. I don't really see the point of rigid. Um, I mean, even if you could, I mean, you could always use fix command or something. You don't really need rigid. Let me show you fix. Does fix exist right here? So when you have a part right here and you moved it to a place where you think it looks okay, you can just click fix, and it's gonna take away all the degrees of freedom. And when I hit Control Alt and try to drag it around, it's gonna have the same behavior. It's not gonna move anywhere. So I don't really understand why rigid exists, but it does, I guess. Um, that's that. So that was a slider connection and a rigid connection. And while I'm at it, I'll just go over the cylinder connection as well. Let me get rid of this. And we did slider, we're going to do cylinder. Let's do cylinder. So again, it's asking you for axes of alignment, and again, it can be any linear thing. It doesn't have to be this particular axes. Okay, that's it. Okay, so what I did is I selected the axis of alignment, then I selected two surfaces. It's essentially like a slider connection where I'm going to say the minimum is 0, and then my maximum is, sorry, 0.25. And that's it. So in a cylinder connection, the main difference is it's allowed to rotate. It's allowed to slide back and forth in the limits that we've set for ourselves. So it's only going to slide back and forth in the 0.25 inches, but it's not going to rotate. I mean, it's going to rotate. Sorry. So just remember, slider, no rotation. We can only slide back and forth. Cylinder, there is rotation and we can slide back and forth. Rigid is just static placement. And I think that's it for this video. We'll go over slot connections, and we might even go over the ball connection in the next video. And after that, we're gonna get into some of the kinematic analysis, and after that, I guess we'll get into dynamic. But I'm gonna try to make that into just one large video instead of these small bite-sized videos, because those are better just done as one case study. So prepare for that, I guess. Prepare for a lengthy video, but this is it for now.